Hey guys, we're back, this time with the question that was sent to me by one of you. And I always appreciate when I get questions. You're welcome to send them to me or put them in the comments, and I'll try to create a video that might be helpful to you. If you haven't already, please like and subscribe. This will help me to kind of keep these videos going. But in this case, we're looking at solving for a variable. And not just solving and getting a numerical answer, but solving for a variable in terms of other variables. And let me show you what I mean. And these are two questions that actually came right from the person that had asked me to do this. Now, we always look at order of operations. And if you've ever been on the internet and you see that long string of numbers that are added, subtracted, multiplied, and divided, and it says, what's the answer? And you get this long list of people that are positive that they got the answer right, and all of them are different. What those equations are asking you to do is to use the order of operation, PEMDAS. And if you alternate or if you get wrong or do it in the wrong order, you're going to get completely different answers. Now, the only reason this is important is when we're using the order of operations, when we're solving for a variable, we're not as worried about order of operations. In fact, really, we want to do it backwards, simply because of how it works. And I'll show you what I mean. Now, in this case, the question was, if the surface area of a cylinder is S equals 2 pi r squared plus 2 pi r h, solve for h. And I thought it was interesting. There was a great question, and that was, does this semicolon, is it part of the problem? And in this case, it's not. It just separates the equation from what it's asking you to do. But the reason that's such a good question is in math, you'll notice that we like to use things from English class as part of the equation. We see it with decimals. For a period, we see exclamation marks in factorials. So you do have to be concerned sometimes with punctuation. Is it a part of the problem, or is it just used in the normal way that we use English? So in this case, we have this equation, and we're just going to solve for h. And that's obviously right here. So I'm just going to put this in red and keep it in red so I recognize this is what I'm solving for. So I'm going to move my equation down here, and you'll notice if you're looking at PEMDAS, the first thing that you would want to do is look at parentheses and then exponents. But we're going to go backwards. We're going to look at addition and subtraction. And so we have this. We want to get this by itself. And so we have this being added. So we're going to need to get this to the other side. And if it's added on this side, we're going to need to subtract 2 pi r squared from both sides so that we can get this term by itself. So by doing that, we subtract it from this side, it gets rid of it on this side, and now we're left with 2 pi r h. So we still don't have our h by itself, but we do have this 2 pi r now that we need to get rid of. Since we're multiplying it to our h, we're going to need to divide both sides now by 2 pi r. And so we're going to take this side, divide it by 2 pi r h, that gets rid of it on this side. So our solution then, h is equal to s minus 2 pi r squared all over 2 pi r. Now, that seems like it's a little complicated, and you think, when am I ever going to use this? And there are times actually when you want to get an equation where you just want to solve for one variable. Maybe you have the numerical values for all of the other exponents, and you just want to have it in a form that you can just plug and chug. This is one of those ways to do it. And really, when you do this in mathematics in a section in your textbook, it's usually just to practice how you're solving for equations. Now, let's look at the second one. This one says the average acceleration of an object, a equals v1 minus v naught all over t. And in this case, we want to solve for v1. Now, v sub 1 and v naught, those are usually to indicate the volume the velocity at certain positions in time. So we want to now solve for v sub 1. So I'm going to go ahead again. I'm going to put it in red. And what I like to do, anytime I have an equation that has a fraction in it, if it's possible, I like to get rid of the fraction right from the beginning. It just makes working with the equation easier. And a lot of you I know don't like working with fractions. And sometimes you're going to end up with the fraction at the end, and that's okay. But sometimes it's easiest to look at what's happening when you get rid of the fraction from the beginning. And that's easy to do when you have an equation, because all we're going to do is find the lowest common denominator throughout the whole equation and multiply both sides by that common denominator. Well, in this case, we only have one denominator, so we're just going to multiply both sides by t. And that gives us then on this side a times t. The t's cancel here, so we get v sub 1 minus v sub naught. Now, we're trying to find this v sub 1, so we need to get rid of this. Since we're subtracting on this side, we need to add v sub naught to both sides so that we can isolate that v sub 1. So by adding it, we get a times t plus v sub naught is equal to v sub 1. And that's what we were going for. So just using the order of operations backwards will help you at least understand what steps to take. But you can play around with it. There's a lot of times in math, one of the things I love about math is many times there's multiple ways to do things. And as long as you're keeping the rules of mathematics, you can do it different ways and still come up with the correct answer. I would get comfortable with doing things a very specific way and in ways that will make sense to you. Just make sure that those ways are also accurate. Now, again, if you have questions that you'd like me to address, please send them to me or throw them in the comments and I'll try to create a video for you. But thanks for watching. And again, if you have not yet done it, please like and subscribe.